friends, let's do another question on optimizing volume and surface area. So in this question, Ali is designing a can with a volume of 350 milliliters. What's the minimum surface area of the can, and determine the dimension of the can with the minimum surface area. So once again, let's start by opening this up so that I can derive my surface area formula. So I know that a can is a cylinder, and the area of my top would be pi r squared. This is my height. I once again here have pi r squared, and then this top part of my rectangular portion is going to be the circumference of the can, so 2 pi r. I have my first equation for surface area. Surface area is 2 pi r squared, one for the top and one for the bottom circle, plus length times width, so 2 pi r times h. Now, this is the value that I want to optimize. The second thing that I know is I have a volume of 350 milliliters. Now, 350 milliliters is equivalent to 350 centimeters cubed. This is my fixed value. I also know that volume of a cylinder, I'm going to take the base area and then times it by the height. So pi r squared times h. These are the two equations I'm going to work with. And now I'm going to take my volume and rearrange my volume so that I could fit it into my surface area. 350 centimeters cubed is equal to pi r squared times h. Let's isolate for h. So I have h is equal to 350 divided by pi r squared. I know what pi is, so I can simplify that one. 350 divided by 3.14, 111.5 divided by r squared. Now let's take that value and substitute it into my surface area. So surface area is equal to 2 pi r squared plus 2 pi r times 111.5 r squared. Now I can either clean up this equation or I can just throw it into the calculator. I'm going to put it into Desmos now. Desmos. Two times 3.14 times x squared plus 2 times 3.14 times x times bracket 111.5 divided by x squared. Close my bracket, and I have a very thin one. Let's change our view. Let's make our x. Okay. So we see that our minimum, let's write that down. going to sketch just the first quadrant. In the first quadrant, I have a minimum value, and it's 3.82 and 274.9. I know that my y value is surface area, and my x-axis is my radius. So it tells us this can will be optimized when my radius is 3.82 centimeters. So optimized surface area at radius is equal to 3.82. Surface area is 274.9 centimeters squared. Now, we also need to find the height, and we're going to go back to our equation. Height is 111.5 divided by r squared. We're going to substitute our r squared in. $111.5 divided by 3.82 squared. 7.6. So our new optimized can will have a height of 7.6, a radius of 3.82, surface area of 274.9 centimeters squared, and a volume of 350 milliliters, or you could say 350 centimeter cubed.